Hello students, hope you are doing well. In this video, we are going to discuss campus design consideration part 2 of Unit 3 Designing Basic Campus and Data Center Network for the subject Enterprise Network Design of B7 Semester IT, University of Mumbai. In this lecture, we are going to cover part 2 environmental characteristics and consideration, network geography consideration, and transmission media consideration. Part 1 is already covered in previous lecture. The campus environment, including the location of the network nodes, the distance between the nodes, and the transmission media use influences the network topology. So here in this lecture, we will examine the environmental characteristics and consideration. So first thing is network geography consideration. So in this network geography consideration, intra-building, inter-building, and distant remote building is considered with respect to the network geography. The location of enterprise campus node and the distances between them determines the network's geography. Node including end user workstation and servers can be located in one or multiple buildings. Based on the location, nodes, and the distance between them, the network designer decides which topology should interconnected them based on the required maximum speed, distance, and so forth. So already seen these geography structures with respect to the network geography are intra-building means within the building, and between two or more building, and from some other location, that is distant remote buildings. These geographic structures are very important, and there are some guidelines how to use them. So first thing is intra-building structure. Intra-building structure, this we are going to discuss. So what is inside that? An intra-building campus network structure provides connectivity for all end nodes located in the same building and give them access to network resources. The building access and building distribution layers are typically located in same building. Like here one building is shown. So in this particular building, building A, if the whole network is there, then it is coming under intra-building. Okay. User workstations are usually attached to the building access switches in the floor wiring closet with twisted pair copper cables. Wireless LANs can also be used to provide intra-building connectivity, enabling users to establish and maintain a wireless network connection throughout or between buildings without the limitation of wires or cable. Now, access layer switches usually connected to building distribution switches over optical fiber, providing better transmission performance and less sensitivity to environmental disturbances than copper. Depending on the connectivity, the requirement to resources in other parts of the campus, the building distribution switches may be connected to campus core switches. Now come to second part is inter-building communication. So here it shows the inter-building network structure, sample inter-building network structure. So there are different elements like switches are there, layer 3 switches, layer 2 switches, and different nodes are connected to these computers. In this figure, an inter-building network structure provides connectivity between the individual campus buildings. Central switches in the building distribution and or campus core layer. These buildings are usually in close proximity, typically only a few hundred meters to a few kilometers. So the distance between these two building. Okay, here these two building, the distance may be 100 meter to less than 1 kilometer, not more than that. Because the nodes in all campus buildings usually share common devices such as servers, the demand for high-speed connectivity between the building is high. Within a campus, companies might deploy their own physical transmission media to provide high throughput without excessive interference from environmental conditions. Optical fiber is the medium of choice between buildings. Depending on connectivity requirement to resources in other parts of the campus, the building distribution switches might be connected to campus core switches. Next is distant remote building. So in this distant remote building, when connecting building at distance that exceeds a few kilometers but is still within a metropolitan area, the most important factor to consider is the physical media. The speed and cost of the network infrastructure depend heavily on media selection. If the bandwidth requirements are higher than the physical connectivity option can support, the network designer must identify the organization's optical application, critical application, and then select the equipment that support intelligent network services such as quality of services and filtering capabilities. These filters allow optimal use of the bandwidth. Some companies might own their media such as fiber, microwave, or copper lines. However, if the organization does not own physical transmission media to certain remote location, the enterprise campus must connect through the enterprise edge using connectivity options from private service providers such as traditional WAN links or Metro Ethernet. The risk of downtime at the service level agreement available from the service provider must also be considered. For example, inexpensive but unreliable and slowly repaired fiber is not uh, desirable for mission critical application. Now come to transmission media consideration. An enterprise campus can use various physical media to interconnect devices. The type of cable is an important consideration when deploying a new network or upgrading an existing one. Cabling infrastructure represents a long-term investment. It is usually installed to last for 10 years or more. The cost of medium, including installation cost and the available budget, must be considered in addition to technical characteristics such as signal attenuation and electromagnetic interference. A network designer must be aware of physical media characteristics because they influence the maximum distance permitted between devices and the network maximum transmission speed. Twisted pair copper cables, optical cables or optical fiber cables, and wireless like satellite, microwave, and IEEE 802.11 LAN are the most common physical transmission media used in modern networks. Let us talk about copper cable. These are the copper cables available: Cat1, Cat2, Cat3, Cat4 up to Cat7. The speeds are for Cat1 up to 1 Mbps, it is twisted pair. All the cables are twisted pair and it is connected in old telephone network. 4 Mbps speed is provided by Cat2 and token ring network. It is typically used in token ring network, and this is token ring and base T Ethernet. This speed is 10 Mbps, 100 Mbps is Cat5, and it is used as Ethernet, fast Ethernet, and token ring. 5E up to 1 Gbps. It is again Ethernet, fast Ethernet, gigabit Ethernet, Cat 6 and Cat 6A, 100 meter. Maximum length is 100 meter. Here very small length and it is not quoted. And in case of Cat 7, it is also up to 100 meter, and this is gigabit Ethernet, 100G Ethernet or 100 meter Ethernet. So, twisted pair cable consists of four pairs of isolated wires that are wrapped together in plastic cable. Like here, we can see different cables: Cat 3, Cat 5, Cat 6, Cat 6A, and Cat 7. These are the example of twisted pair, and twisting is also given. In Cat 3, only three pair of cables are showing. With unshielded twisted pair (UTP), no additional foil or wire is wrapped around the core wires. This makes these wires less expensive but also less immune to external electromagnetic influences than shielded twisted pair cable. Twisted pair cabling is widely used to interconnect workstation, server, or other devices from their network interface card or an IC to the network connector at a wall outlet. The characteristic of twisted pair cable depends on quality of material from which they are made. As a result, twisted pair cables are sorted into categories like category 5 or greater is recommended for a speed of more than 100 Mbps per second. Category 6 is recommended for gigabit Ethernet because of possibility of signal attenuation in the wire. The maximum cable length is usually limited to 100 meters. One reason for this length limitation is collision detection. If one PC start to transmit and another PC is more than 100 meters away, the second PC might not detect the signal on the wire and could therefore start to transmit at the same time, and this will cause the collision on the wire. So instead of gaining high speed, it will result in lowering the speed and delay in the packet transmission. One of the main consideration in the network cabling design is electromagnetic interference. Due to high susceptibility to interference, twisted pair is not suitable for use in environment with electromagnetic influences. Similarly, twisted pair is not appropriate for environment that can be affected by the interference created by the cable itself. Some security issues are also associated with electromagnetic interference. Hackers with the access to cabling infrastructure might eavesdrop on the traffic carried across UTP because these cables emit electromagnetic signal, so they can uh, capture your data. Distances longer than 100 meter may require long reach Ethernet (LRE) is Cisco proprietary technology, that is LRE, long reach Ethernet, okay, provided by Cisco, that runs on voice grade copper wires. It allows higher distances than traditional Ethernet and used as an access technology in WAN. Now come to optical fiber. There are two type of optical fiber, single mode and multi-mode, and further it is categorized into step index, graded index, and so on. So let us discuss what is the use of optical fiber. Typically, a typical requirement that leads to selection of optical fiber cable is transmission medium include distance longer than 100 meters and immunity to electromagnetic interferences. Different type of optical cables exist. The two main type are multimode and single mode. Multimode fiber is optical fiber that carries multiple light wave or mode concurrently, each at slightly different reflection angle within the optical fiber core. Because mode tend to disperse over longer length, model dispersion. Multimode fiber transmission is used for relatively short distance. Typically, LEDs are used with multimode fiber, and typical diameter of multimode fiber is 50 or 62.5 micrometer. Then come to single mode. It is also known as monomode fiber. It is typical optical fiber that carries single wave or laser of light. Lasers are typically used with single mode fiber. The typical diameter of SM or single mode fiber core is between 2 to 10 micrometer. Single mode fiber limit dispersion and loss of light and therefore allows for higher transmission speed, but it is more expensive than the multimode fiber. Both multimode and single mode cable have lower loss of signal than copper cable. Therefore, optical cables allow longer distances between devices. Optical fiber cable has precise production and installation requirement. Therefore, it costs more than twisted pair. Optical fiber requirement, it requires a precise technique for cable coupling. Even a small deviation from ideal position of optical connectors can result in either a loss of signal or large number of frame losses. Careful attention during optical fiber installation is imperative because of traffic's high sensitivity to coupling misalignment in environment where the cable does not consist of single fiber. From point to point coupling is required and loss of signal can easily occur. So you might have seen the installed optical cable in your home. Nowadays, it is very common like Geo Fiber and Airtel Fiber. They are installing and providing services through optical cable. So these are very high speed, and you can see that when installation person is coming, they are equipped with several instruments, and on the basis of these instruments, they provide alignment and they are checking what error is there. If no error is there or almost there, the error is inside transmission limit, then they install the optical fiber in your homes. Now come to wireless. The inherent nature of wireless is that it does not require wire to carry information across geographic areas that are otherwise prohibitive to connect. Wireless LANs connect can either replace a traditional wired network or extend its reach and capabilities in building. Wireless LAN equipment includes access point. Here in central, this is access point, base station is there, that perform functions similar to wired networking hub. And PC client adapters, access points are distributed throughout a building to expand range and functionality for wireless client. Wireless bridges and access point can also be used for inter-building connectivity and outdoor wireless client access. Wireless client supporting IEEE 802.11g. This is 802.11g, and so many standards are there. This allows a speed of up to 54 Mbps in 2.4 GHz band over a range of about 100 feet. The IEEE 802.11b standard support speed up to 11 Mbps in the 2.4 GHz band. So you have seen while installing these fibers, they are setting 2 or 3 bands for your network. Okay, so here this band, their frequency limits the speed. The IEEE 802.11a standard support speed up to 54 Mbps in 5 GHz band. Now come to different transmission media type and its characteristics. So the parameters, typical parameters are distance. the range, bandwidth, price, and deployment area. If we are going to use copper twisted pair, it is limited to 100 meters and the speed is up to 100 gigabit per second. It is inexpensive and deployment area is wiring closer. Multi-mode fiber up to 2 kilometer fast Ethernet. Okay, up to 550 meter it works with gigabit Ethernet and up to 300 meter 10 gigabit Ethernet. The bandwidth is limited to 10 gigabit per second. Price is it depends what kind of cable we are using inside that multi-mode fiber. Internode or inter it is used for internode or interbuilding connectivity. Single mode fiber. This is single mode fiber up to 10 kilometer fast Ethernet, up to 5 kilometer gigabit, and up to 80 kilometers 10 gigabit Ethernet, up to 10 Gbps or higher, moderate to expensive. It depends what kind of cable we are using and see SM or single mode fiber is more expensive than the multi-mode fiber. It is used for internode or interbuilding connectivity. Now come to wireless. Okay. So in case of wireless, nowadays what happen? We are connecting through optical and it will transmit the signal wirelessly. Okay. So this may be 802.G or B. Up to 500 meter at 1 Mbps, up to 54 Mbps for means wireless is half duplex. So effective bandwidth will be no more than half of its rate. Okay. And next is its price is moderate. If we purchase wireless router, it is typically 2000 or 3000 rupees. But if we are going to purchase Cisco router, definitely it will cost more. And it is used for internode or interbuilding communication. Now let us discuss each of the parameter like distance. This is the maximum distance between network devices such as workstation, server, printer and IP phones and network nodes and between network nodes. The distances supported with fiber vary depending on whether it supports fast Ethernet or gigabit Ethernet, the type of fiber used and the fiber interface used. Second is bandwidth. Bandwidth is very important. The required bandwidth in particular segment of network or the connection speed between the nodes inside or outside the building. The wireless throughput is significantly less than its maximum data rate due to the half duplex nature of radio frequency technology. Next consideration is price. So along with the price of the medium, the installation cost must be considered like fiber installation costs are significantly higher than copper installation cost because of strict requirement for optical fiber cabling. Then come to deployment, deployment area. It indicates whether wiring is for wiring closet only where users access the network or for intermode or interbuilding connectivity. When deploying devices in an area with high electrical or magnetic interference, for example, in an industrial environment, you must pay special attention to media selection. In such environment, the disturbances might interfere with data transfer and therefore result in increased number of frame errors. Electrical grounding can isolate some external disturbance, but additional wiring increases cost. Fiber optic installation is the only reasonable solution for such networks. Cabling example. In this particular figure, a typical campus network structure and devices such as workstation, IP phones, and printers are no more than 100 meters away from LAN switch. The unshielded twisted pair wiring can easily handle the required distance and speed. It is also easy to set up and price performance ratio is reasonable. The distance here shown in this figure are for sample network. However, the maximum distance supported varies depending on the fiber interface used. Optical fiber cable handles the higher speed and distance they may be required among switch devices. Multimode optical cable is usually satisfactory inside the building. Depending on distance, organization use multimode or single mode optical fiber for interbuilding communication cable. If the distances are short up to 500 meters, multimode fiber is more reasonable solution for speed up to 1 Gbps. However, an organization can install single mode fiber if its requirements are for longer distance or if there are plans for future high speed, for example, 10 Gbps. Selecting the less expensive type of fiber might satisfy a customer's current needs, but this fiber might not meet the need for future upgrades or equipment replacement. Replacing cable can very expensive. Planning with future requirement in mind might result in higher initial cost but lower cost in long run. So this is simple example of cabling like twisted pair is installed here, fast Ethernet up to less than 100 meters. This is if we go for this networking, this is intra building. If we join both then it is inter building. Okay. So with this we finish this lecture. In this lecture we have covered environmental characteristic and consideration, including network geography consideration and transmission media consideration. In next lecture, we will see campus design consideration part 3. Thank you very much. Bye bye.